Welcome to the Graphs of Radical Functions Transformations podcast. All right, so we're going to take a look at these. All right, so you can ignore the top direction there about writing the transformation on the correct whiteboards because we didn't get to do this in class, so we're going to go over it now. And I gave you a little quiz on these to see how you would do and if you understood the transformations based on the activity we did in class on Monday. So let's see if you got these transformations right. All right, I'm going to write them down, and you're going to actually now write them into your notes as well. The vertical translations. All right, so if I add a positive number to my radical, it is going to move it up. So this particular one here would be up 3. Right? That would be our movement. And so it's actually going to be whatever it is we add, that's how far it's going to move up. So this is translate, come on. Yep, well, there it starts to write, but who knows what that says. All right, let's try one more time. Come on, erase. There we go. All right. Usually it just takes a moment, and then it's good for the rest of the podcast. So translate up 3, and this one was translate down 3. Down 4. All right, those were those transformations. All right, so if we add to the radical, to x inside the radical, it's going to move it left and right. If it's negative, it is translating it to the right. So this is translate to right. And this is translate 1 left. So if we add something to x and it's positive, it's going to move it to the left. And those of you who are doing the translations or even looked at the graphs of the translations saw that when they had a positive value, they could add in negative numbers, right? So I can add it, I could put x could be -1. Right? So that means it's going to move to the left. But the smallest number I could use for the y equals the square root of x minus 2 is 2. Right? That's the smallest number I can use. Otherwise, I'm going to get imaginary numbers. And so that one moved to the right. All right, so a vertical compression and stretch. If it's greater than 1, it is a stretch. If it's between 0 and 1, it's a compression. All right, so this one is stretched by a factor of 2. Basically, it's like a dilation. So stretched by a factor, did I say 2? A factor of 6. I don't know whether I'm just still thinking of the last problem. So stretched by a factor of 6. That's an R. And then next to that, it would be a vertical compression. All right, so this one was compressed by a factor of 1/2. Right, so all the y values are going to be half as big. And on the first one, y equals 6 square roots of x, all the y values are going to be 6 times as big. All right, so if instead of adding it to and multiplying it to the whole radical, if it's multiplied by x, then instead of being a vertical stretch compression, it's going to be a horizontal stretch and compression. All right, so here we have y equals the square root of 1/5 x. All right, so this is, and I should have put, actually, I left out the words vertically. I have a hard time squeezing those in. So maybe you can, in your notes, could squeeze that in. I forgot the words vertically. So this is stretched vertically by a factor of 6. And this is compressed vertically by a factor of 1/2. Right, so the next ones, those are the horizontal. So if it is between 0 and 1, it's going to be a stretch, the opposite. Because now I have to add a number 5 times as large. If I wanted to get to just little 1, x has to be 5. So it takes me all the way to 5 to get square root of 1, which is 1. Before it was just 1. Right? So this is going to be a stretch. So over here you can write stretch. If b is between 0 and 1, and then it's a compression if b is greater than 1. All right, so here we have y equals 1/5 x. All right, so that is going to be stretched horizontally. Come on, there we go. By a factor of 5. All right, because that's going to take values that are 5 times as large. Notice that's a reciprocal, right? Because it's the b. All right, so 5 times as large. Notice it says f of 1 over bx. So if it's f of 1 over b, right, and my b is in the denominator there, that means my factor is b. Okay. Now the next one, this one is compressed horizontally. By a factor of 1/3. It's going to grow 1/3 as slowly, right, than it did before, because I don't need as big of values. Right, so I could just plug in little 1/3 and I'm going to get to 1. And so actually it's compressing it horizontally because I need smaller x values. So here I need smaller x values. Let's put that in there. That might help you keep this straight. This is smaller x values and this is larger x values. Right, and then the last one there is the reflection. And if it's in front, this is reflection over y. And this is the reflection over the x-axis. So hopefully these all made sense to you and you did really good on the little practice quiz where I just wanted to see which ones, how well you knew these. And let's graph them all. So you have the graphs in your notes and we're going to graph them. And I think you also have the, I don't know if I didn't put the table in, I just put the statement in because it's going to be very, very similar. All right, so transformations of the cube root. All right, so we have all the same ones for the cube root. So transformations are applied the same way to the cube root function as square root functions. Matter of fact, they'd be applied the same way to any root functions, but we're only going to graph square roots and cube roots. So vertical translation, if we add 3, that one went 3 up, 4 down. 2 to the right, 1 to the left. All the same as we had on the other graph. Vertical stretch by 6, vertical compression by 1/2, horizontal stretch by 5, horizontal compression by 1/3, and across the x-axis and across the y-axis. All the same ones. Okay? All the same ones. So all we have to learn is one set of rules. All right, so we're going to graph the function here. So we want to graph y, we're going to graph both, we're going to graph 2 for the price of 1 on this graph here. So we have y equals square root of x plus 3 and y equals the square root of x minus 4. And I have good old y equals the square root of x on there already. So when we're graphing using translations, and I just kind of plucked him up here. I don't know if he'll move. He is locked in there. So and you know, it looks one way when I'm looking at it at a computer screen. There we go. He's pretty close. All right, so we're going to take those key values there, 0, 0. Oh, they're all stuck together. 0, 0, 1, 1, 4, 2, and 9, 3. And we're going to translate those. And since it's y equals the square root of x plus 3, all of them move 3 up. So 1, 2, 3. Ah, the orientation, 1, 2, 3. Guess who didn't orient? 1, 2, 3, and 1, 2, 3. And you know, I may end up having to orient first and make this 2 podcasts. I think I might. I think I'm going to orient right after this particular graph. So it'll just be part 2. All right, now let's graph the next one here. All right, and so now the next one just moves down for it. 1, 2, 3, 4. And 1, 2, 3, 4. See, I'm just moving my points. 1, 2, 3, 4. I'm moving those key values. 1, 2, 3, 4. And there we go. Let's label these graphs. So this is y equals the square root of x minus 4. And this one is y equals the square root of x plus 3. And I'm going to take a quick break. I'm going to, domain and range. And then I'm going to take a quick break, orient the board, and we'll start in with the next graph. All right, so the domain here. All right, now let's look at our graph. Do you see any x values that are on the negative side? I don't see any x values on the negative side. Matter of fact, the smallest number I see in terms of x is 0. I do see an arrow, so it's going to keep on going. So that is the domain for actually all 3 of these functions have that as their domain. The range is different for the 2 functions. So we have 2 different ranges here, and I graphed them all in one graph. So we have range 1 and range 2. So I'm going to write them to match their colors. All right, so for the blue graph, notice that the smallest value we have is 3. So the range here starts at 3, and it keeps on going. For the red graph, our range is -4 to infinity. Right? So notice if we translate the function up and down, it's going to affect our range, because normally y equals the square root of x would start at 0, 0. All right, I'm going to orient the board, and I'll see you in just a minute. All right, bye for now.